All right, we're back. So we're going to do another Extrema example problem. And this time the function is going to be f of x is equal to 2x minus 3x to the 2/3. And it's also going to be closed interval from -1 to 3. First thing we're going to want to do is find the derivative of this so we can get this party started. So f of x, f prime of x, is going to be equal to 2 minus, so if we drop the 2/3 here, you'll get 2x to the -1/3 power for the derivative. Okay, another way to write this would be to do this right away, you should look at this and see, okay, I can simplify it a little bit, put these two terms together, and you would end up getting, right away you should see a domain restriction problem here. We cannot put 0 in for x, so that means that x is definitely, that 0 is going to be a critical number for this function. So I'm going to write down x equals 0 for a critical number over here. Also, you can set it equal to 0 and try to solve for x to see what values will make it be equal to 0. So what I really need to do is focus on this top part right here, because if this is 0 and this is non-zero, then this is going to be equal to 0 over here. So I'm going to put 2x to the 1/3 minus 2 is equal to 0. 2x to the 1/3 is equal to 0. Divide both sides by 2. I end up with x to the 1/3 equals 1. If I cube both sides, another critical number I get will be x equals 1. If I cube both sides, x equals 1. So that's another critical number. So we need to now see if these critical numbers actually yield a relative extrema. So I'm going to make my number line like so. I have 0 and I have 1. So I'm going to test one side of the 0 and put -1 in for the derivative. So you end up with 2 minus 2 times -1 to the -1/3 power. So if you actually put this into your calculator, you will end up with a negative value. So if we test -1, this side of the 0, and you put it in here, you will end up with a positive number. So if you put -1 in here, you'll end up with a positive number. If you put in 0.5 into this, you will get a negative number. So this means that 0, x equals 0, is in fact a local max because it's going from positive to negative. So, or yeah, local max, or I can just write relative max for this one. Now we're going to do the same thing with the 1. So we'll plug in 2 over here. So you end up with 2 minus 2 times 2 to the -1/3 power. So if you plug in 2, you'll end up with a positive value. So this shows that 1 is going to be our relative min. So both of those check out. And then we still have our endpoints of -1, x equals -1, and x equals 3. So now we need to test all 4 of these to see if what kind of extrema they are, if any. So we're going to have 0. If you plug in 0 in this original function, you will get 0. 1. If you plug in 1 here, you'll get 2 minus 3, which is -1. Right here you have -1. If you plug in -1, you will get -5. And then last but not least, for the 3, you will get 6 minus 3 to the cubic root of 9 for this one. Okay, so now based on all these, you should see that the max, so we already know that this is going to be the relative max. This is going to be the relative min, be a relative min. This endpoint right here is going to be your lowest value of -5, so that is going to be your absolute min. And this right here, this ends up coming out to be neither of them, so then our absolute max would also be the 0, 0 term up here as well. Okay, so that's finding all the extremas for this problem using critical numbers and checking the endpoints as well. If you have any questions on anything in this video, let me know.